All right, here's a riddle for you. An electric train runs at 60 miles an hour heading south toward a wind blowing at 30 miles an hour. What is the direction of the smoke from the train? The answer is there is no smoke from an electric train. So there you go. Anyway, this is the meat of the lesson today. In the last couple of videos, you guys saw what polar graphs look like. And the one thing I really wanted to stress about those polar graphs and about the ones that you'll be graphing is the polar graphs are nice and smooth, and they're always nice and smooth. There's a starting point, and and they typically go on forever, depending on how long you want to draw them. Sometimes they repeat themselves. Sometimes they don't. This particular graph goes on forever. But I mean, just like a line, like if you graph the line y equals 3x plus 1, that line would go on forever. You don't draw it forever, you just kind of draw part of it. And the part of it that's as close as you can get to the origin. And in this case, we're drawing polar graphs. So you're going to learn some basic techniques to draw polar graphs. And it's really quite similar to drawing graphs in the xy plane. You're going to find in this case, we're going to find an r and a theta. If you notice, my r is kind of messed up here. I started drawing an x. But you're going to be finding an r and a theta, and you're going to be plotting a bunch of points and connecting the dots with a curve. And just like you did in the xy plane, you put a bunch of dots, and sometimes you need two, sometimes you need more, and then you'll go ahead and connect the dots. So let's start by choosing, and in this case we have the coordinates r theta. So you learned about that. We learned r theta, and we normally when we're graphing an xy, you pick the x and then you find the y, but because y is a function of x, and here r is a function of theta. So we're going to pick our theta first, okay? And normally we just pick 0. For an angle of 0 radians, what in the world is going to be our r? Okay, well, if r is equal to theta, then we know that r is 0. And we can plot that point. Let's plot it with a nice thick marker. Okay, so 0 radians, 0 radians, and a 0 for radius, and we just have a dot right there at the pole. Okay, and then let's pick an angle that is an easier, one of these angles here. Let's pick pi over 6. And again, this is the easiest of all the graphs you'll graph, r equals theta. So if r equals theta and theta is pi over 6, then r is pi over 6. And so pi over 6, though, how far is that? Well, pi is about 3, and so that's about 1/2. Okay, and notice here that we've got, what I did is I marked off a little extra line in here because we're going to get, the graph's going to get pretty big pretty fast. So each one of the circles represents 2 units. Okay, so this unit right here represents 1, 1, 2, 3, probably label that, 1, 2, 3, 4, 5, 6, 7, 8. So 1/2 is r, and theta is pi over 6. So we're going to go towards pi over 6, 1/2. So it's really kind of crammed in here. So about right there. And since it is kind of crammed in, let's pick a bigger value. Let's pick pi over 2. Pi over 2. And so since r is equal to pi over 2, then pi over 2 is about 1.5. Okay? So towards the pi over 2 radians, we go 1.5. It's somewhere about like that. So hopefully you're starting to see something here. Hopefully you're starting to see, hey, as theta gets bigger, well, r is going to get bigger. Well, you already saw the graph. We graphed it in the last video. Well, maybe you didn't watch the video. But let's pick pi. That's about 3. Okay, so I'm just giving approximations here. That's all you really need is approximations. We're just trying to get an idea what the graph looks like. So 3 in the pi direction. 1, 2, 3. 3 comma pi. And that's that way. So pi is this way. You know where pi is. And 3 towards that. So far we have this. We've got this guy here. 1, 2, 3, 4 points. let's pick 3 pi over 2. And what's that? So just estimate pi to be about 3. 3 times 3 is 9, divided by 2 is 4.5. So it's about 4.5. So 1, 2, 3, 4, 5 would be there. So 4.5 would be somewhere right about there. And again, you can visualize this as theta gets bigger, so is r. And so what we get is we get a spiral. So we get a spiral just getting bigger and bigger. 2 pi is about 6.28. 3 pi, 3 pi is about 9. So anyway, that's all we need is to graph from 0 to 2 pi. So this is, remember, 0 to 2 pi, stops there, and it would just keep getting bigger and bigger and bigger. The spiral would just continue to get bigger and bigger. Okay? So what I want you to do is, I'm challenging you right now on this graph to the right to graph r equals negative theta. Okay, so that's what I would like you to do right now. Graph r equals negative theta. Okay, pause the video. Gosh, I did it again. So we have r and theta. When theta is 0, r is 0. So again, we get that point right there at 0, 0. Okay, if if theta is pi over 2, then r is negative pi over 2, so negative 1.5. So instead of going towards pi over 2, we go away from pi over 2, negative 1.5. Okay. It would be good though to get one of those, to get a since our second point is on an axis, we don't know what direction it's going in, so we need to get a value like pi over 6. So when theta is pi over 6, r is negative pi over 6, so like negative 1/2. Okay, so instead of going towards pi over 6, we go away from pi over 6, and we go negative 1/2, so right there. So we can see the curve is starting to go like this. Okay, starting to get bigger right there. Okay, and then let's pick now pi, and again it's about negative 3, so instead of going towards pi, we go away from pi. 1, 2, 3, so right about there. So we can see that as theta gets bigger, r is also going to get bigger, but r is going to be negative. So instead of, instead of going this way, like we had r equals theta, we're going to go this way. And then let's pick 3 pi over 2. And again, that's about 4.5, so negative 4.5. So instead of going towards 3 pi over 2, we go away. 1, 2, 3, 4.5, right about there. And we just see we get here, and then let's see, 2, 4, 6.28 is right about there. So that's what the graph would look like. Okay, do a couple more in the next video. And actually, let's do this. I'm going to have you guys do a couple, try these on your own and see if you can figure out what they look like. So we're going to graph r equals 1 plus cosine theta. And so that's one of them. So this is your student practice here. And in the next video, I'm going to just show you the solution. 1 plus cosine theta. I'm going to have you do r equals, and the next one, r equals 2 plus cosine theta. Okay, so these I want you to try on your own. Okay, down here, we're going to go r equals 1 minus 2 sine theta. Okay, and then we're going to go r equals cosine of 3 theta down there. So this is my challenge to you. Without your calculator, do your best, plot points, do exactly the way we did it up there. Plot points and see if you can figure out what these graphs would look like. This would be a really helpful exercise to go through. And I will actually show you the solutions in the next video, and then we can talk about these in class. Have a great night.